Welcome to the video for Lesson 2 of the Turn the Lights On curriculum. This lesson introduces the different types of engineering systems that generate electric current. In this video, we will go over power generation and power distribution grid, identify the criteria and constraints, discuss electrical power generating system prototypes, generating plants, and go step by step through the lesson. At the end of this lesson, students will be able to describe the concept of a power grid and how it works, define the criteria and constraints of the engineering design problem. So, in the introduction, we will first review the engineering design process and problem scoping. Then we will look at concepts related to electrical power and the power distribution grid. The activities will be based on understanding the electrical power and the power distribution grid, how to get started with the prototype and define the problem, and criteria and constraints. This lesson can be completed in 3 50-minute class periods. So let's get started with the introduction part of the lesson. The two main concepts in this lesson are electrical power and the power distribution grid system. Students will develop an understanding of the system that allows distribution of electric current from power plants to homes. Students will implement a preliminary prototype of the electrical power generating system to better understand the problem. Moreover, we will also revisit the engineering design process from the previous lesson and see how learning these new concepts can help us move along in the design process. We will look at the electrical power generating system and the power distribution grid in detail, as well as problem scoping. In the beginning of this lesson, students will be working on problem scoping, where they are going to continue working on defining the problem and learning some scientific concepts that will help them to solve the problem. Ask students to remind you of the problem that they need to solve. Then use the engineering design process poster and students' engineering design process sliders to help students identify what they have done so far and what step they are currently on, which is define. Move the poster and sliders to the define step, since the students are going to identify the problem that they need to solve, including identifying the client and end users. You can pause this video to watch the activity video titled Students' Questions for the Client for more details about how to conduct this activity, where you will provide answers to questions that students asked to the client in Lesson 1. You can get to this video in the link below. Next, review what they have learned about the problem so far from the letter and the questions that they asked the client. Use the Define the Problem worksheet to have students individually answer the questions about criteria and constraints. We will provide more details about this activity later in this video. Now you will explain about criteria and constraints. There are some examples available in Item 4 of classroom instruction in the curriculum document. Challenge students to tell you some criteria or constraints of the engineering problem they are trying to solve. In the next part, they will learn more about the problem to gain a better understanding of what must be accomplished with the design. Next, students will gain a better understanding of what they need to accomplish with their design. Work with the students to identify that this means they are moving into the learn stage of the design process, and move the paperclip on the engineering design process sliders. For an introduction to electrical power generating systems and the electrical grid, present the video Electrical Grid 101, All You Need to Know, which explains how the power grid works. If you want, you can also pause this video now and watch that video from the link below. Assess where your students are in their knowledge about electrical power. Based on your experience in teaching science, you can spend additional time reviewing the concepts which students usually have a difficult time understanding. Have students answer the following questions, first individually and then as a full class discussion. The questions are, what are the main components of an electrical power grid? How does a power grid work? And which generating plants do you see in the video? You can find answers to these questions in Item 5, Classroom Instruction, in Lesson 2 of the curriculum documents. Take this opportunity to remind the students of our engineering problem. Design the power generation system for the power grid. Namely, we need to decide which generating plants will use fossil fuel power plants, hydropower plants, wind turbines, or solar panels, how many of them there will be, and where we should locate them. Notice how these concepts are organized in a way that students can learn how to apply the things they learn in science while working on an engineering project in this curriculum. You will see that this organization is also mirrored in the activities you will do in this lesson. Help students see these connections so that they can see the real-world application of their science lessons. Check the examples of electrical power generating system prototypes provided in the curriculum. These examples are intended to help you understand the final prototype of the student's design. You should not show them to the students to avoid bias in their reasoning process. Their final prototype should inform the quantity and type of each power plant chosen, how many megawatts each of them generates, the total construction cost, and the total operating cost in dollars. Take a moment to look at the example in this slide. Here, we have a possible prototype for an electrical power generating system. It includes one fossil fuel power plant that can generate 50 megawatts of power, one small hydropower plant that can generate 30 megawatts of power, 5 wind turbines that each can generate 30 megawatts of power, for a total of 150 megawatts, and 5 solar panels that can generate 10 megawatts each, for a total of 50 megawatts of power. Therefore, the whole system can generate 280 megawatts of power. The total construction cost is $460 million, and the total operating cost is $11.9 million. Included here is an image representing a possible prototype for the example just given. This is a second example for the prototype. Observe in the image that the figures corresponding to each type of power generation were placed over the map and organized in the range of the original Gallagher power station that is being replaced. Pause for a moment and look at the numbers and types of each power generation plant, their location, and the cost to construct and operate this system. For this lesson, have each team start designing their power generation system with the prototype materials. Here are a few examples of the materials. See the complete prototype materials in the PowerPoint document named materials.pptx. There, you will find the board map and the generating plant models. Also, pass out the information sheets of each generating plant to the teams. Tell students that we are going to create our prototype by using a scale map of the region where they're going to locate the generating plants. Let students get familiar with the board and context maps, which is a section of Floyd County. Next, tell students that the Indiana Office of Energy Development has already identified 4 types of generating plants that we can use in our electrical power generating system. These plants are fossil fuel power plants, small hydropower plants, wind turbines, and solar panels. Explain to the students that the suppliers of these plants sent information sheets about each type of generating plant. At this point, each team should have the information sheets handy. Ask them to consider all of the information to make evidence-based decisions. Ask students to read the titles and briefly explain what they are about. Students will learn more about the science related to power generation in upcoming lessons. Students have the option to choose between 4 types of generating plants: fossil fuel power plants, small hydropower plants, wind turbines, and solar panels. Each one generates different amounts of electrical power, conveys different impacts upon the ecosystem of the area, has different construction and operating costs, and occupies different amounts of land area. All this information is summarized in the information sheets for Lesson 2. It is likely that your students have learned about one or more of these generating plants before or heard about them. Ask students what they know about them and use this discussion to highlight the role of these generating plants in electricity generation. Now it's time to begin to work on the initial prototype of the electrical power generating system for the electrical power grid of New Albany. The purpose of this activity is to help students get familiar with the material and reflect about the complexity of the engineering problem. Some things that engineers need to consider when working on complex problems are: what do they need to learn? How do they know if the solution works? And how long does it take to address a real problem? Emphasize to the students that this initial prototype doesn't need to be perfect. The focus here is on where and how many generating plants they should place in their system. For that, ask pertinent questions that will help them reflect on these important points. You can ask, where do you think we should locate the plants? Do you think we can place a wind turbine in the middle of the forest? For this prototype, we are going to assume that we have enough wind and sunlight across the available area. However, we only have fossil fuels in the yellow area of the map, which is from worksheet 1C. This is an important constraint of our design. As the students work in their designs, encourage them to think about how to evaluate their prototype. How will they know that their design accomplishes the expectations of the client? If some teams finish fast, you can encourage them to compute how much power they're producing. As an engineering side note, point out to students that solving real engineering problems may be frustrating and overwhelming sometimes due to the uncertainty and lack of knowledge. To deal with this, engineers break down the problem in more manageable tasks and spend a lot of time working on each small step to have a successful design at the end. Students will have the opportunity to learn more about energy generation concepts and to design and redesign their prototypes. In this stage of the lesson, students will individually answer the questions about criteria and constraints in the worksheet 2A. Suggest that they find information in the client's letter, which was worksheet 1B, and also in the answers from the client. When they finish answering the questions on their own, instruct them to share their responses in their design teams. Review the students' answers as a whole class discussion. Guide the discussion so students will end up with the following criteria and constraints to evaluate their electrical power generating system. First, the electrical power generating system should provide at least 280 megawatts of power. The generating plants, which are fossil fuel plants, small hydropower plants, wind turbines, and solar panels, should be located near the energy source. The electrical power generating system should look to minimize the environmental impact. The total construction cost should be less than $510 million. The total operating cost per year should be less than $20 million. You should write the criteria and constraints on something like poster paper or a whiteboard and keep it visible throughout the unit. The students will need to review this information several times throughout the engineering unit. For your convenience, we provide a full sheet in the appendices with this list of criteria and constraints for you to print out. The activities in this lesson will focus on defining the problem, identifying the criteria and constraints, and understanding the power distribution grid system. In this video, we will only look at the pedagogical aspects for these activities. For the step-by-step video of how to conduct these activities, you can check the activity video for this lesson. The link for this video is below. The activities are related to electrical power generating system prototypes, defining the problem, and identifying criteria and constraints. In teams, students will design a preliminary prototype of the electrical power generating system. You need to prepare the materials for the prototype in advance, a board map and the generating plant models. The board map is an A2 size. This is where students are going to locate the generating plants. See Figure 1 on this slide. There are two options for building the map. You can plot full-size maps using the file boardmapfullsize.pptx and paste it on cardboard or a similar hard paper. If you do not have a large format plotter available, you can also print out 4 sheet maps from prototype_materials pptx, cut them, and assemble to make a full-size map for each team. You can place the 4 sheets together according to Figure 2 in the curriculum document. For the 2A Introduction to the Problem activity, students will individually answer the questions on the Define the Problem worksheet, up to the questions about criteria and constraints. When students finish answering the questions on their own, instruct them to share their responses in small teams, decide what their team answer is, and write down the revised answer on the Define the Problem worksheet or directly in the students' engineering notebooks. If some teams seem to be struggling with a question, address it as a whole class. There is also Worksheet 2A answers that are available in the curriculum for Lesson 2. There, you will find possible answers for the questions as well as the criteria and constraints for the electrical power generating system. After the activity 2A, now it's time to wrap up. Ask students to take a picture, or you can take pictures of their prototype as a first model of their electrical power generating system. They will continue working on this prototype after Lesson 5. You can finalize the unit, reminding students what they have learned in this lesson and that they still need to learn more before they have a final solution to the problem. You can ask, what else do you think we need to learn to create a successful electrical power generating system design? Ask them to individually answer the final question on the Define the Problem worksheet, worksheet 2A. You can review the concept of the electrical power generating system, criteria, and constraints. Ask questions to review the student's learning process, such as what was the most difficult part for them? How was their work as a team? What else do they need to learn or do to design a successful solution? Now take some time and plan for how you will implement Lesson 2, especially the prototype activities with your students. Take notes in your curriculum document about things you want to remember and perhaps add information about timestamps from this video that may help you later when you want to review. When you are ready, proceed to the Lesson 3 video.